Limits. This is the notation for limits. It's read the limit as x approaches a of f of x is equal to L. A will be a given number. F of x will be a given function. L will be a number, and it's the answer that we seek. This is a description of limits. It's not an exact definition, but it's a good way to start understanding limits. And to start understanding limits, today we'll look numerically. Let's start with an example. Let's start with the example that says the limit as x approaches 3, the function in this case will be x squared minus 4, and let's see if we can't figure out what that'll be equal to. We'll use this example to try to understand what this description is saying. And since we're going to do it numerically, we'll make a table of values. On one side we'll put x, on the other side we'll put f of x, and in this case f of x will be this function right here, x squared minus 4. If we follow our description, it says we should take values of x closer and closer to 3, but x not equal to 3. So on this side, we put values of x that are getting closer to 3, but x not equal to 3. We took values of x that were both greater than 3 and values of x that were less than 3. But the overall trend as we go down is x is getting closer and closer to 3. Now we take out our calculator, and for each value of x, we substitute it into this function x squared minus 4, and we calculate the corresponding value. And this is what we get, and we can see the trend. As the values of x on this side are getting closer and closer to 3, the value of a is going to be equal to 3. That's what we had said. The corresponding values of f of x on this side are pretty clearly getting closer and closer to 5, and in this case, L will equal 5, and that will be the answer. Of course, in this case, it would have been simple enough to tell the answer just by taking this 3, substituting in 3, getting 3 squared minus 4, and coming up with 5. So let's look at a more complicated example so we can figure out better what this x not equal to a business in our description is all about. For this example, let's look at the limit as x approaches 1 of this function, x to the 1/3 minus 1 over x minus 1. In this case, it's not so simple to just plug in 1, because if we do, we get 1 to the 1/3 minus 1 divided by 1 minus 1. And that is equal to 0 over 0. And 0 over 0 is not defined mathematically. It doesn't make any sense. It's not the answer. So that means that we're going to have to work harder to figure out what the answer is, because the answer isn't 0 over 0. We might call 0 over 0 the form of the limit. And in this case, we would say the form was indeterminate. We're going to proceed numerically. We're going to make a table of values again. And on this side again, we'll put x. And on this side, we'll put f of x. And f of x in this case is equal to our function, x to the 1/3 minus 1 over x minus 1. And we'll follow our description. The recipe says take values of x closer and closer to 1, but x not equal to 1. So that's what we'll do in this first column over here. It's very important that we take values of x not equal to 1 in this case, because 1 leads to this problem of 0 over 0. We take out our calculator. For each of these values of x, we compute the corresponding values of f of x, and again, it's going to be clear to see what the trend is. As we go down this column, we see that we picked values of x. We picked this column so that the values of x going down will get closer and closer to a equals 1. That was the whole idea. That was the description. And we look and observe to see if we can see the pattern on this side, and sure enough, we can see that these values, as we go down, look like they're getting closer and closer to 0.3333, and all sure enough, it turns out to be 1/3, and that is the answer. This was the numerical approach to finding limits, and it was cumbersome because we had to compute a lot of values. It works as long as we can get the value of x close enough to a. It fails if we don't get x close enough to a. But it's a good way to start understanding what this description means.